All right, guys, this is Miss Ramos here, and Miss Carlos in the background. Shout out to her for motivating me to do this video this time. If you notice, I have my handy dandy colors right here available for us to go ahead and do today's notes. This does go on page 9, okay? It does go on page 9. So if you were absent today, it does go on your page 9. We are going to talk about page 7. Page 7 of your notebook, it looks like this. So if you could also remember, we're going to go back to a few notes. Today we're going to be talking about properties of a rhombus. Now, a rhombus is the next parallelogram we want to focus on, and it includes all the properties of a parallelogram as you see here. Well, now I'm going to go back to the flow chart. And if you notice on the flow chart, the parallelogram then kind of becomes a rhombus because it's kind of like a son or a daughter. This would be the mom and this would be the son. It has some characteristics that comes from the family member. So that's why it comes directly, or the 6 characteristics you see here listed come from a parallelogram into this rhombus. So if you notice, I'm going to walk you through those properties. Okay. A parallelogram has two, or it has a set of or 2 pairs of parallel lines. It also has opposite sides are congruent. Number 3, opposite angles are congruent. We ask you how many pair of blank interior angles it has. Basically, the word we are looking for is the word consecutive. Remember that a parallelogram has 2 pairs of parallel lines, so it has still consecutive interior angles, along with another word we could use, which is same side interior. And if you remember from last time, it has 4 of them. It has 2 on the top, 2 on the bottom, and then this side, and then this side right here, these 2. The diagonals of this rhombus still bisect each other. That has not changed. And we still have diagonals that create alternate interior angles. So now let's talk about the rest. So the rest of this are the 3 new plus these, right? These 3 new properties. And let's talk about them a little bit more. With the rhombus now, we have 4 congruent sides. And if you notice, I'm marking them to show that they're congruent. Congruent does mean equal, remember? And so I'm going to write here the word 4 congruent sides. And we're hoping you're writing this too, right? Or reviewing the notes that you've already taken. Now we're going to move to this one right here. And you know, I forgot a word up here, so I'm going to put a little line here. And I want to remind you that we're filling in the blanks. We're also talking about some symbols we see here. I hope you see this little 90-degree angle symbol. It's represented by this little backwards T. I'm going to go ahead and put the little backwards T here as well, okay, so you and I could be on the same page. This backwards T means 90 degrees. So the intersection of these diagonals right here, which I'm going to make in orange, because remember, I want to make sure that I'm using some of my color here. The intersection of these diagonals create 90-degree angles. So I not only have this angle, but I have this one here, that one here, and this one here. The last property you see here involves also still the diagonals, but the diagonals do something interesting for this point. The diagonals of the rhombus bisect each other. Bisecting means we go back to what we did earlier this semester when we had a bisector. It wasn't a diagonal though, but it was a bisector. And we had a pink angle. In this case, let's call it angle S. And then angle S was bisected, creating two equal angles, and we used the color green to figure that out. So now let's talk about other things you might want to be careful or see. And we're going to talk about this diagram and directly write the information down here. If you notice, this property had us look at 90-degree angles. And so what I want you to do basically is we want to break up the pictures. We want to break up, like if this was a puzzle, we want to take this away and we want to go ahead and just kind of put the puzzle pieces here. And as I'm doing this, I'm hoping you see something cool. I'm hoping you see 4 what? 4 right triangles, right? You see how I see them right here? And maybe putting the letters here, like putting RS can help. Maybe putting QR could help. Maybe this helps facilitate the reason or why I may have pulled it apart, right? So now I'm also going to put these red marks. Remember the red marks that we started with right here? So it can help us figure out why is she doing this. Oh, I'm sorry, I put that in the wrong place. I'm going to go ahead and white it out in a few seconds. So as you can see, this creates what we call 4 scalene right triangles. And right triangles because they have 90-degree angles there. Scalene basically means all sides are not the same. We also know that the diagonal still acts as a bisector, right? It still bisects each other. So at this point, I already know that this side right here would be the same one as this one. And because this is the same diagonal, I'm going to put the same mark right here. All right? So now we have this diagonal, which corresponds to this part of the triangle, and that part, which I'm going to go ahead and make in another color. I'm going to use the color pink. For you, those of you guys that love the color pink. Okay? So there, we got it. All these marks symbolize that we have scalene triangles. Do you see? No triangle has any of the equal marks. The reason I talk about 4 scalene right triangles is in some of these problems, you're going to be expected to find a missing side. Back in IM1, you learned a squared plus b squared is equal to c squared. And I want to remind you of that today. A and B really do not matter as long as you remember that the furthest side away from the 90 degrees is always a hypotenuse. That I'm also going to go ahead and highlight in yellow. So you can see that this hypotenuse is also the side of the rhombus. You see how I'm doing that over here as well? You see how I'm adding the yellow? I'm also going to add the yellow down here so you can see that I've broken it down and that this is always, this always will match the top. It's just that these are condensed, or these are separated, and when we condense them together, they create that one. So let me go ahead and write down a squared plus b squared is equal to c squared. And this should help you find any of the missing sides if you're asked to do so. All right. Then we're going to move on to this part right here. If you notice, we did talk about angle bisector. So I'm going to go ahead and I'm going to just recopy this part you see right here. So I'm going to take my pen and I'm going to recopy RST. Okay? And I'm going to make that angle in pink because I already talked to you that this right here is what? It's an angle, but it's going to be bisected by my diagonal. It's going to be bisected by my diagonal. Bisecting means that I'm going to cut this angle into 2 equal parts, okay? So to represent that, I'm going to go ahead and use green and green like we did earlier in the school year. So The diagonal is bisecting. I'm going to go ahead and put Q, because if you notice Q, it's the same letter you see here, okay? So let's do a what if. What if I gave you the measurement of the angle RST and I told you that it was equal to 50? Would you be able to tell me the measurement of RSQ or the measurement of QST? And the answer would be yes, right? If this whole angle is 50 and this is acting like a bisector, then this angle would be 25 and this angle would be 25. You see how together both of these angles make that 50, which would be that pink. Back in the days, we did 50 equals green plus green. Remember that? That should ring a bell. The last thing we want you to look at has to do with still the same diagram, but the fact that you will have isosceles triangles. And with that, we're going to use our handy dandy Post-it to make sure we can cover a few things. I wonder if you're able to see, this right here. You see, this means isosceles, right? It means those two angles are equal. So for this case only, I'm just going to copy one, but I want to show you that there's one here. There's another one, right? Two. There's a third one right here, right? And there's a final one over here in this corner, okay? So I'm just copying one of them, remember? I told you I would be copying R, S, Q. And I'm going to copy these marks too. So I'm going to have a green, right? I'm going to have a green here, another green here. And then I'm going to have my R, which has two marks. And then I still have my red to signify that I do have all sides congruent. So now we have a triangle that has two base angles that are congruent, and so therefore it's an isosceles triangle. Okay guys, I hope it helps. I'm not an expert by all means. I know Miss Carlos did an excellent job, but I do thank her for asking me to go out of my comfort zone and try to record this message. Oh, I have one more thing actually, I'm sorry. We're gonna go ahead and work out a problem here.
It's from the homework.
From the homework. Okay, Miss Corrales blew it up, because you know how I write very little. Okay, so remember to have these notes available because we're going to go back to them, but this is the problem. I'm trying to just make sure that it's under the document camera so you can see it. Okay, so I think Miss Corrales forgot a letter. She ate a letter here. So let me try to quickly figure out what it was. Or she forgot a...
No, it's delete the measure, I think.
Oh, I think I'm deleting the measurement. And you're just finding...
Just the side.
Oh, sorry, you're just finding the side. Sorry, guys. It's almost the end of the day. We're tired. We're getting ready for the football game, Excited. You know who's going to win? Go Spartans. All right. So you are finding the measurement of dB. And Miss Corrales said this, remember? She said that we want to basically block what we're trying to find. Because we don't care about that. We know enough information that we're going to just try to find the whole thing, okay? So let me block it more so you don't try to see what's under here, right? It is problem G in the homework. So what I first would do is I'm going to go ahead and label AE. And AE is 3 centimeters. AE is right here. And I'm going to go ahead and put it in orange, right? From my handy dandy handout, I do know that diagonals bisect each other, so that means I can put another 3 over here, all right? Then it tells me that DE is 4 centimeters, all right? So now with another color, let me go ahead and use pink. I could go ahead and put 4 here, because that's what they gave me, right? And so I could put another 4 here if eventually they wanted me to find the whole side. So I'd be ready to find DB if they were asking me for that. Now, I wonder if I can find the outside sides, and the answer is yes, right? I can find that because I know that diagonals also create 90-degree angles, so that means I could do this. It means I could do this. I could create a 90-degree angle right here. And so now I have an a squared plus b squared is equal to c squared, right? I have an a squared plus b squared is equal to c squared. Again, I'm going to be using the yellow right here. And I'm going to remind you that all sides are congruent, right? So once I find that one, I pretty much have found everyone else. All right? So ready? We're going to do a squared plus b squared is equal to c squared. Remember, the hypotenuse plays a role here. The side plays a role of the hypotenuse. So we have an a squared plus b squared is equal to c squared. And apologies that I'm writing a little tiny and you can't see what I'm writing. So I'm going to go ahead and put the 3 there. I'm going to go ahead and put the 4 there. And so that equals c squared. Sorry, I should have been consistent. I should have put the 2 in pink as well. All right, so now if we're using a calculator, we can calculate this really quickly, but we hope that you do know what 3 squared is, which is 9. And we do know that, we hope that you know that 4 squared is 16, and that does equal c squared. Okay? Then we do know if we're adding this, we do get 25. And then somewhere when we were little, we took the square root of both sides, and we know that this answer is 5. So this means that this hypotenuse or side is 5. So it means all the way around we could put 5s. So now it's like, okay, let me see what they were asking. Let me see what they were asking us to do. Wow, they were asking us to find DB. DB, do we have DB? Yes, we do. DB would be 8. And AD would be 5. See, this one used a diagonal. This diagonal right here. This one used the side, which is why we needed to use Pythagorean theorem. All right, guys. I'm done now. Have a good weekend, okay? See you on Monday. Remember to work hard and hit it hard with the math.